Are you ready to talk about forms and accessibility? Yeah, okay. But first let's do a sound check. I'm gonna have a lot of screen reader demos, so let's make sure it works.
Accessibility.
Is the sound good? All great? Cool, then let's start. So accessibility is all about ensuring equal access for people with disabilities. And you likely are familiar with accessibility features in public spaces, such as curb cuts, ramps, elevators, and sliding doors. They help to remove barriers for people with disabilities. But similarly to how curbs can be challenging for somebody using a wheelchair, some of the features of our digital products can create barriers for people using assistive technology, like a screen reader, voice control, switch device, or braille keyboard. And one of the most common examples are different types of forms, be it creating an account or logging in, buying and paying for things, searching, sending messages, and more. Often the only thing standing between the user and their goal is a form. Which is exactly what I want to focus on today. This talk will be a practical guide on how we can build forms accessibly. We'll use this sign-up form as an example, and I'll walk you through implementing various accessibility features in it. We'll start from the things that are really simple and move to more advanced topics as we go. But first, let me introduce myself. Hello, my name is Kateryna. I'm Ukrainian, living in Estonia. I work at a company called Buffer as an engineering manager leading the front-end direction. And without further ado, let's get started because we have quite a lot of ground to cover. And I want to start by going through some of the foundations of web accessibility. So on the web, everything starts with HTML. It describes our page structure and its contents. But on its own, HTML is just a long piece of text. It doesn't do anything. So in order to display something, browser needs to parse it. So it transforms it into a DOM tree, which then gets rendered into the visual UI that you can see and interact with. However, it doesn't end there. In parallel to this process, it also builds an accessibility tree, which contains all important accessibility information about elements on the page, which then gets exposed to assistive technology via a special API from the browser. But it's a lot easier to understand when looking at the example. For this HTML page, accessibility tree will look something like this. Note that not everything present in HTML is included within the accessibility tree. Some of the things that we used for styling are omitted that don't contain any important accessibility information. Each element within the accessibility tree has its role, which describes what kind of element it is, what is its purpose, and an accessible name, which identifies it on the page. In case of the button, it is inferred from its content. Additionally, it can contain a lot of other attributes that describe it further or communicate its current state. You can actually see all of this information within the DevTools. You can inspect both individual accessibility parameters of elements on the page, or you can see the full page accessibility tree. And it's super useful for debugging or finding problems within the application. Now, this accessibility tree gets exposed to assistive technology, like a screen reader, and will be used to navigate the page. Let's see what that might look like.
Page. Web content. Heading level 1. Hello. Waving hand. Image. Main. Let's learn about accessibility. Start button.
As you can see, or rather here in this case, screen reader announces information straight from the accessibility tree. It uses accessible role and name to announce element on the page. While in this example, we navigated the page sequentially, screen reader users have a lot of shortcuts to navigate it by headings, interactive elements, links, and so on. And this is exactly why using semantic HTML is so important. While we could make anything in HTML look like a button with some additional CSS, it won't give out any information about what kind of element it is to somebody who cannot see all of the visual cues. Therefore, when we use semantic HTML elements like element button here, we can convey meaning behind our code, additionally to getting a lot of built-in behaviors for free. And there's more than 100 different HTML elements that we can use that come with built-in semantics, different roles, states, and other attributes. And by using them, we can make our code more meaningful and more accessible. Now that we understood a little bit more how accessibility and assistive technology works in the context of web, let's get back to forms. And let's talk about labeling first. Because imagine filling a form like this. It seems confusing, right? Unfortunately, this is the experience for a lot of people using assistive technology. And therefore, it's important that we label our inputs properly. Our sign-up from before used placeholders to describe inputs. Well, this is a very common practice, and you can see a lot of UIs doing that. It has several important accessibility concerns. First of all, they are a lighter shade of gray, so they are less legible. But also they disappear as soon as you start typing. So it might be harder for people with cognitive disabilities to keep track of inputs, especially in long forms. But also they all have low support in assistive technology, so likely can be completely ignored by screen readers. Therefore, it's better to have a clear, visible label near the input. So let's see how we can implement it. There's a label element that we can use, and when positioned near, it will already visually convey the information. But if we go and navigate via screen reader, we'll hear.
Edit text, blank.
So you can see it doesn't really pick up this label. To understand why, let's look into the accessibility tree. Currently, our text input doesn't have any accessible name. And it's because screen reader doesn't recognize that this label belongs to this input. So to fix this, we need to explicitly connect label element and input element together using for and ID attribute. In case of React, we use HTML4. Now, contents of the label will be used as an accessible name for the input, and therefore will be used to announce the element on the page.
Username, edit text.
Perfect. Now, with labels, our form is already a lot more accessible. While we should generally strive to have clear and visible labels all the time, there are still a lot of cases within the UIs where we might not want to display a label, or the purpose of the control is really evident from the context. So let's do a little detour and talk how we can implement hidden labels as well. And search box is a really good example of that. So let's see how we can implement it. First of all, what we can do is we can just position labels similarly as we did before, but we could hide it from the visual UI. If you would use something like display none, it will actually hide this element from accessibility tree as well. Therefore, we can use a technique called visually hidden. It is a CSS class that we can add that under the hood kind of shrinks this element and hides it out of the viewport without taking up any space. And it is a really common technique that we can use in a lot of different cases where we might want to hide something from the visual UI. However, it will still be within accessibility tree, so it can be used to announce this element on the page. It also can be really handy in React to create a component for specifically this purpose, something like visually hidden. And this component needs to support polymorphism with something like an as prop. So you can customize the semantic element it is rendered as to have better semantic support. And there are a lot of really good use cases for it. For example, implementing accessible icon buttons where you can hide label within the button using visually hidden. But now, if we actually look in our code, we have a label like word text twice. So what if we could use our button, our search button, as a label for our input? To understand how to do that, we need to learn about ARIA. ARIA stands for Accessible Rich Internet Applications. And we just learned that in HTML, a lot of the elements come with built-in semantics. And for modern user interfaces, we often need more flexibility. And this is exactly what ARIA is for. It is a spec that defines a lot of additional attributes that we can use to complement native HTML with. We can set different roles, states, and other properties to improve how they are perceived by assistive technology. For example, using the role attribute, we can set an accessible role on the elements. Divs, by default, are a generic container, so they don't provide any meaningful semantics. But by setting a role of the button, it will be represented as a button within the accessibility tree. However, important to note that ARIA doesn't change behavior or appearance in any way. So we can treat ARIA as a promise. We are promising to the user that this is supposed to behave like a button, and it should behave as such, and it's important to fulfill that promise. In order to do that, we would usually write a lot of JavaScript, CSS, and HTML, and as you can see, it actually takes quite a lot to build a button. So in most of the cases, we should prefer native semantic HTML elements, and they generally have better support in assistive technology. However, where ARIA roles shine is implementing interactive patterns that don't exist in native HTML, like feeds, tooltips, tab lists, switch, combo boxes, and so on. And ARIA helps to provide semantics, but you would need to implement the behavior yourself. Additionally to roles, there's a lot of different ARIA attributes. They're all prefixed with area-something, and in our case, we can use area labeled by to use non-label element in order to provide accessible name for our input. So we can connect it again by ID here, and in that case, contents of the button will be used as an accessible name for the input, and will be announced like this.
Search text field, blank.
Yay, it works. Now, additionally to area labeled by, we actually can use another area attribute called area label. I intentionally put it last on purpose because to me, among the 3 options that we just discussed, it is the worst out of the 3. We can set area label on the input and we'll override its accessible name here. However, while area label is generally quite useful, we need to understand that it also has some accessibility downsides. For example, it won't get translated if the browser translation feature is on. But also, I find that we as developers, often with the best possible intentions, tend to overuse area label in many cases. For example, here, it is just not necessary, because button contents are already providing an accessible name. But in some cases, it actually can be quite harmful, like here. Because, for example, users who use voice control, they need to speak out names of the interactive controls on the page in order to activate them. And because visible name in settings, they will say something like click settings, but because accessible name is overridden, the button won't take effect. It brings me to the first and really important rule of ARIA that is called no ARIA is better than bad ARIA. So when you're utilizing any ARIA attributes, make sure that you're not harming the experience of the users in the process. Now we just learned how to provide visible labels, but also hidden labels for our inputs. And let's talk how we can guide users even further by providing different hints and instructions. We usually would display these somewhere underneath the control, like here. To implement it, we can place the text underneath. However, there is a gotcha. A lot of the screen readers have what is known as form mode. As soon as they encounter a form, they change their navigation strategy and start prioritizing interactive controls. Therefore, text nodes, like here, might be completely overlooked by the screen readers. But there is a better way. We can use an accessible description. When we talked about accessibility tree, I said that they can have accessible role and name. But also, a lot of the elements can have an accessible description, which is empty by default. We can set it using another ARIA attribute called ARIA described by. Here, we can, again, using ID, set an ID to our span element and connect it to our input. And this will set accessible description in the accessibility tree, and usually it is announced after a pause, like this.
Username, edit text, must be between 3 and 20 characters long.
As you have noticed already through several examples, when implementing accessibility features, we often need to use IDs in order to connect different elements together. But IDs also need to be unique on the page, and therefore it can be sometimes a little bit challenging to come up always with the new IDs. To make it easier, React has this really handy hook called useID, so you can just use it in order to generate unique IDs, like so, and then connect different elements together within your HTML. Now that we've learned how to provide hints and instructions using accessible description, let's talk about how to mark required and optional fields in an accessible way as well. For example, in our sign-up form here, we have 3 required and 2 optional fields. And by clearly indicating which is which, we can guide users through the process more smoothly and decrease the chance of mistakes. The most common way to mark required fields is use this red asterisk symbol near the label. Let's see how we can implement it accessibly. First, we can just add an asterisk in the label, but if we navigate there using the screen rule here,
Username star, edit text.
as you can see, it actually pronounces the symbols, and it is the case with many elements that we might use for decoration, like different icons and separators. Therefore, we need a way to hide it from the accessibility tree. And yes, there's another ARIA attributes for that we can use called ARIA hidden. Everything that is positioned within something with ARIA hidden attribute set to true will be hidden within the accessibility tree. But now we have the visual cue, the red asterisk. We also need a way to provide semantic cue as well. We can do that, for example, by using required attribute in HTML. However, together with the semantic cue, it will also introduce the native HTML validation, which might not always might be what we want, because it sometimes can be not very flexible and might behave inconsistently in different browsers. So in most cases, you might want to implement your own validation instead. So we are kind of in a situation where we want to have the semantic cue, but we don't want to have the associated behavior. To do that, we can use another ARIA attribute called ARIA required. It will set required within the accessibility tree, but the validation won't be triggered, and will be announced like so.
Username, required edit text.
So now we've marked required fields, and while this is a common approach, you might also want to consider marking optional fields instead. This way, the form can be perceived as less threatening, but if you do that, I still recommend you leave a semantic area required attribute on the required fields. Now we've just turned off the default HTML validation, so let's talk about how we can implement our own validation and error messages within the forms. Because the way that we validate user input and display errors can have tremendous impact on the user experience as well. But before diving into implementation specifics, let's consider a few important aspects. First of all, we generally use color quite a lot in the user interfaces to differentiate between different states. Red for errors, green for success messages, and so on. However, different people perceive color differently. And therefore, to avoid this color trap, it is best to use also additional way to convey this information. And for example, adding an icon would already make it a lot more universal. Now getting back to our form. Another pattern that I often see is that if the user input is incomplete or incorrect, the submit button is made disabled. I would recommend to avoid doing that, because disabled buttons cannot be navigated into via keyboard and create a dead end for the user and prevent them from understanding what exactly is missing or incorrect. So it's usually better to keep the button enabled, but validate user input when the form is submitted. Now let's see how we can implement these input level error messages. So right now, to indicate that this input has some invalid data, we are using this red border and display an icon. But similarly to how we have the visual cue, we again need to provide a semantic cue as well. To do that, we can use another ARIA attribute called area invalid. And when set to true, the screen will actually announce that this input has some invalid data. One neat trick that I really like to use is that we can actually use all of these ARIA attributes for styling as well. I like this approach because, first of all, it's easier. You don't need to add additional CSS class. But also, it is really reliable. And make sure that all of your semantic cues and visual cues are always in sync. Now, we marked our input as invalid, but we also need a way to communicate the error message as well. We can use the same approach as we did with hints before. We can set an ID and add it to our accessible description. Area described by can actually accept multiple IDs, and then we'll concatenate the contents when announcing to the user, like this.
Username, required invalidate to edit text. This username is taken.
In addition to displaying inline error messages near individual fields, especially in longer forms like ours, it is a good idea to display an error summary for the whole form. But here we also need to consider an experience for somebody who cannot see the UI. So as a sighted user, I click the submit button and I see a lot of these red things flashing at me from the screen. But for folks who cannot see all of these visual cues, we need to find a different way of notifying them of the changes. And which brings me to another really important and powerful feature of ARIA called live regions. It allows us to specify certain places within the page as live. And then these areas will be watched. And no matter where the screen reader is currently positioned, when something changes within that region, it will get notified, and therefore can announce this change to the user. We can set it with area live attributes, which support several settings. It can be polite, meaning that we'll wait for whatever it was saying at the moment before announcing the change, or it can be assertive, meaning that we'll interrupt the speech for the announcement. And this is a very powerful feature to communicate different notifications, statuses, errors, which is exactly what we need. To use it, we can just set area live to assertive, and then as the user submits the form without losing current focus, they will receive notification like this. Like this. Oh, not like this. I think everything just went down, and my laptop, I need to, it died. Yeah. So that happened, yeah. Now it has this loading screen and kind of loads everything. Yeah, it's my laptop that turned off for some reason. Okay, let me find where we were, and I will restart it. Oh my God, it opens all of the windows I had. Okay. We were here. I think so. Yes. Let's try again. Okay, where we were. Like this. Okay. Oh, now audio disconnected. Can we turn the audio on?
Sign up button. Sign up failed. Username and email fields are invalid.
You heard that, right? Okay, okay. I'll just put the volume on. Yeah. Cool. So instead of setting area live directly, we can also use a role alert that will, under the hood, set it implicitly for us. We can use the same approach to communicate success statuses as well, so it doesn't need to be errors only. So you can, again, set role alert, and the user will be notified. Now what we implemented is submit validation. But in some cases, we want to provide faster feedback to the users. So let's talk how we can implement instant validation as well. For example, for our username field, we might want to provide feedback instantaneously as the user inputs different usernames into the field. To do that, we can actually utilize the same approach. We can just set a role alert to our input level error message, and therefore, when something would change, it will get announced to the user. We can use the same approach for less important information. For example, character count, like here. So we are updating, but in that case, it is not as important. Therefore, we can set area live to polite instead, or use a role status, which will achieve the same purpose. Live regions are really powerful and really useful. However, also many notifications can create a lot of disruptions and create confusing experience to the users. Therefore, we need to be careful when we utilize these. Now we've covered quite a lot of ground on the forms already, so let's look how all of these things work together in a demo. And let's hope my computer doesn't die this time.
Username, required edit text. R. Username is too short. A-M-B-E-R-E-H. This username is taken. 2. Username is available. Email address, required menu pop-up edit text email. Display name, required menu pop-up edit text. Kateryna Porshnieva, window. Website, edit text URL. About you, edit text. Sign up, button. Sign up failed. Email field is invalid. About you, website, Kateryna email address, k.porshnieva@gmail.com, window. About you, sign up, button. Account created. Check your email for confirmation.
Yay, it worked. Before wrapping up, let's also go over a few ways that we can test whether our implementations are accessible. First of all, there are a few automated accessibility testing tools. We can use XDevTools. Lighthouse also has some accessibility violation checks. There's also really useful ESLint plugins called ESLint JS6 Ally that can check for a lot of different violations in how you use your roles or other attributes in your JS6. However, there's only so much that we can validate automatically. Another way that I really like that can also serve as a really gradual way to introduce accessibility as part of your workflows is when you're doing automated testing. So if you're writing unit or integration tests, let's say with testing library, you can push yourself to use more semantic selectors and matchers instead. So instead of reaching for something like test IDs or get by text, you can use semantic selectors like get by label tags that will already check that the label is correctly bound to the input within the accessibility tree. Or we can use get by role, which works not only for native HTML elements, but also for all the accessible roles like alert that we use to communicate errors. We can also use accessible matchers. So for example, we can check that elements are required using to be required, which goes into accessibility tree and checks that it is set there semantically. Or we can, in the same way, we can check that something is invalid. Oh, it happened again. Okay. It's restarting. Yeah, that probably happens when you have more than 100 slides, I guess. Yeah, please stall a little bit. Yes. Thank you. You came to the rescue.
All right. Somebody name out a Dan. Name it. Bet. That's too much effort. Cross. Alright, what's that? The what? Gangnam Style? Alright, what else? You good? Alright.
Thank you. There's a little bit left, so I hope we won't have any interruptions. So we can also check that there's some invalid data, or if it is valid. Okay. Or if it is valid. We can also make sure that elements have an accessible description that, for example, we use for hints or for errors. And generally, if you think about it, your test runner, similar to the screen reader, cannot see the UI. So by pushing yourself to find semantic ways of testing your logic, you can identify gaps, but also learn a lot more about accessibility. Other frameworks like Playwright support similar syntax as well. It's also great to test things with the screen reader. So if you have a Mac or an iPhone, VoiceOver comes built in. On Windows, you can use NVDA or JAWS, and also there is a talkback on Android. I know that if you haven't used screen reader before, it can be quite intimidating and confusing. So there is this really good video series on YouTube by Rob Dodson that covers quick guides to different screen readers. And naturally, as you, as developer, would use screen reader very differently to actual person with disability would. So if you have an opportunity to engage with users of your product with disabilities, I really recommend you do. It's something that we do at Buffer quite a lot, and it has been really insightful for the whole team. But if you cannot do that, there's also services like Fable that can connect you with people with disabilities, and they can provide useful feedback on what needs improvement within the UI. As the last thing, I want to note that accessibility is not something that's black and white. And by learning more and doing small incremental improvements, we can make progress and move towards a more accessible and inclusive web for everyone. And by this QR code, you can find more additional information, like different links and links to different screen reader guides and everything I covered, plus PDF version of my slides. And thank you so much. I'm sorry for all of the interruptions, but I hope you still found this useful.